and welcome to episode 9 of Dielectric Videos. So on today's episode, I'm going to be doing a product review of the Sentech Power Inverter series. Now this is the series of power inverters produced by Harbor Freight Tools, and as you probably already know, there's kind of somewhat of a controversy as to whether or not these are good value inverters. They are relatively inexpensive. If you apply your 20% coupon, you can get this little one for about $16, this bigger one for about $25, and the large 750 watt one, which is installed inside this toolbox, which you probably saw in my previous video, for about $60. So the question, of course, is, are these a good value inverter? Are they reliable? Do they work well? And do they meet their, or come close to their nameplate ratings as far as their power output? Well, in my experience so far, these have actually been pretty darn good inverters. I've modified this one with an EC5 connector so that I can connect it to my Volt Power G06 power brick, which I'll show in a later video. And I've also made this adapter for the small inverter, which also allows me to connect it to the power brick, like so. Now, as you can see, the small inverter has a car accessory plug adapter, and using this adapter cable that I made, this allows me to plug it into the power brick, like this. I will show you that in a moment. But my favorite of these three inverters is definitely this little mini inverter, because it's super compact, very inexpensive, and it's reasonably powerful. This is an 80 watt with 125 watt peak power inverter, and it actually does provide roughly 80 watts. I can charge my 80 watt hoverboard with it, and it has no trouble supporting that. I can power my laptop, I can power a work light with it. Anything that's relatively small load under, say, 80 to 100 watts runs just fine on this. It's been reliable, I haven't had any problems with it, and in fact, I've actually used an identical inverter to this one, at least the circuit board out of it, as the inverter for this power box. This power box has the same circuit board in it that this inverter does. The only downside of this little inverter is the fan. It is quite noisy. When it spins up, it does, I'll move it near to the camera, and as you can hear, it is really quite noisy. It's not such a problem if you put it on the floor, but if you want to, say, power your laptop at school or something, it can get quite loud just running in the background. But that being said, it is a relatively robust inverter. I've overloaded it a couple of times with various loads exceeding 100 watts. It does have a thermal cutout within, so it will protect itself to an extent from overload, and it does produce a reasonably reliable 120 volt power output. I haven't had any issues with this inverter or with the other small 80 watt inverter. Now the next inverter that I will show you is the 400 watt inverter. This is the upgraded, bigger version. It's a 400 watt continuous, 800 watt peak inverter, and this one has two plugs, as you can see, and a USB port. By the way, this inverter also has a USB port on it. Now, just a word of caution, I do not recommend using these USB ports with anything of great value. I've taken this inverter apart, and in fact, there is a small buck converter that directly converts the 12 volts DC in to the 5 volts DC out that this inverter claims to be able to produce. It does work, but of course, if anything goes wrong with it, you're going to be sending 12 volts into your device, which could be catastrophic. And because these are relatively inexpensive inverters, it is possible for them to fail, and honestly, relatively likely, especially if they're put under a high demand for the USB port. So getting back to the 400 watt, this one also has a USB port and two receptacles on it. It does work quite well. I haven't actually brought a load. The only load I've brought I'm actually going to be showing you in a minute with the bigger inverter to demonstrate its actual power output. But for this inverter, I can show you by plugging it in that it does in fact work. It powers on, the little green light comes on. One thing to watch out for, the only Sentech inverter I've ever bought that had to actually be returned was a 400 watt unit like this. When I first bought it and turned it on, there was, you'll notice there's a little orange light before it turns green, or kind of a reddish green light when it first comes on. you want to see that. The one that I originally bought that was a 400 watt would instantly go green and wouldn't turn red when you switch it off, and it actually would never turn on its fan. It worked for me for about a week, and then something inside shorted out, there were some sparks, and it didn't work anymore. I did end up taking it back and getting a replacement, and this replacement has given me no trouble for quite a few months of service. However, if you get one and it does instantly go green without any sort of a warning or startup, it's a good idea to be wary of its reliability. Now, that being said, that is the only inverter that I ever had a problem with. All the other inverters that I purchased from Harbor Freight, all the other SendTech inverters, have been really reliable. I haven't had any real issues with them operating. The only thing I should probably mention is these are modified sine wave inverters, not pure sine wave inverters. And what that means, if I can get this paper out, is that they don't produce the characteristic sine wave that would look on a voltage versus time graph like this. Instead, they produce what's called a modified sine wave, which is essentially a square stepped wave. Well, it's more like this, that actually would approximate, let's ignore that, that would actually approximate the sine wave, like so. Now, the approximate sine wave like this is, the reason for this is that it takes a lot less waste heat to switch a transistor on and off rapidly than it does to gradually switch a transistor on and off. Now, you can buy pure sine wave inverters that produce the pure sine wave. They're just more expensive, and sometimes the efficiency is not as good as the pure sine wave inverter. These inverters claim, I'm not sure if it says on this one, but on their data sheet, they claim to be up to 87% efficient, which is not bad for a modified sine wave inverter. Now, the issue with having these square waves in the sine wave instead of the pure sine wave is that a lot of devices, especially devices with transformers in them, will not work very well. Usually most things will work with these inverters. However, not everything will. And things that do work with them will sometimes run overly hot and have other issues. Let me show you an example with this inverter, which is, as I showed in a previous video, my isolation transformer. Now, this is a big iron core transformer, which you would expect to be relatively quiet if running on an AC main signal. If you watched my video about this transformer, you would have seen that it is very quiet. Watch what happens when I plug it into this inverter. Now, as you can probably see, if I tilt the camera slightly, the light is on. It is generating power. And in fact, if I were to plug something into this, you'd be able to see that it does actually work. Well, I don't have actually something with me to plug into it right now, but you can see the light is on, it's generating power. That's not so much of an issue. But it is horribly noisy right now. You can hear it buzzing and making this horrible harmonic sound. Now, this transformer has a high enough thermal mass and thermal momentum that it could probably run like this for a very long time before getting hot. However, it would likely begin to overheat if left on an inverter like this indefinitely. Now, since this transformer doesn't have much of an issue, I'll just let it stay on. But smaller, less thermally massive transformers, especially transformers inside like audio equipment and sensitive electronics, might not fare so well. And it's actually possible over the long run to damage those electronics by running them on these modified sine wave inverters for a long time. So that is something to keep in mind and be wary of, because even though the inverter does produce 120 volts, you can measure it as such, not every device will play nice with the modified sine wave output. So I'll disconnect this transformer from the inverter, and I'll set it back down on the floor, and I will move on to the next inverter. Let me just unplug this one here. The next inverter I wanted to go into is the Harbor Freight 750 watt inverter. Now, you saw in my toolbox video that you really can't see the inverter. It's underneath the lithium polymer batteries, and it's been quite heavily modified to actually fit in the box and operate with this switch. However, it is still the same inverter inside here, and you'll have to take my word for it, but It is a 750 watt, 1500 watt peak, or so the datasheet says, power inverter. Now to demonstrate that, I have brought this high-powered work light out. This is a halogen work light with a 500 watt bulb in it. It's not going to be pushing the inverter to the very limit of 750 watts, but what you'll notice is the fan will make quite a bit of noise when I power it on. Now as you can see, this thing's drawing a ton of power. There's probably a lot of lens flare on the camera, so I'm going to actually turn that around for you guys. Now, as you can see here, it is sagging the battery voltage down just because it is drawing a huge amount of power. This would be approximately 50 amps at 12 volts. So 50 amps is currently being drawn out through these batteries. It's going to gradually discharge them, but of course this is a 20 amp hour power box, so it should run for at least 15 to 20 minutes before getting completely depleted. Maybe less because of the lack of efficiency of the inverter and the fan. But as you can see, it is running and the output is staying on, the light is on, and the lamp is lighting to full brightness. So it is working very well. The 750 watt inverter is a powerful beast. It runs you about $60 to $70 depending on whether you have the 20% off coupon for Harbor Freight. And it really, I have not had any trouble with it. I've been using this toolbox for weeks and weeks, or no, months and months actually. It's been a lot longer than that. And it hasn't given me any issues. So I would definitely give the 750 watt inverter a positive review. It's a good value for the price. It's a relatively powerful inverter, and it has so far been pretty reliable. In that case, I'd like to show you the last part of my demo, and that is my vehicle adapter. So I actually, since I've been using the EC5 connector, which is what came with my portable G06 power brick for basically all of my inverters, I've actually made a car plug adapter, an accessory plug adapter, that allows you to connect any EC5 device to your 12 volt car receptacle. And of course that then allows me to connect this inverter to it via the connection here, and really anything else that has the EC5 connector. This is essentially the counterpart to this other adapter, which allows me to plug the already accessory plug-ready inverter into the EC5. It would be a bit pointless to do this, but just to demonstrate that it works, I can plug this into this, plug this into the power brick like so, and the 400 watt inverter has power. So this allows me, of course, to plug the 400 watt inverter into my car's power receptacle, but with it makes it so I don't have to unscrew the lugs if I want to, say, plug it into my power brick instead. Now the only thing to be careful of is because this is a 400 watt inverter, it could draw up to and above 40 amps from the car, which of course is enough to blow the fuse on your accessory plug. Most accessory plugs are only 15 or 20 amps, so you have to be slightly careful about not overloading the car by using this. However, it does provide a nice stable source of 120 volts for the long road trip or for the impromptu need for power on site. Say you don't have a generator and you need to be able to power your audio system. Well, this is a great choice for that. It gives you a good amount of power and it'll run off your car or run off of a portable battery like this one, which I will cover in a future video. So, I do recommend these inverters. You do have to keep in mind you shouldn't use these for any ultra-critical applications because I have had one fail in the past. I would say they're a good value, they're a good cheap inverter. If you're on a budget and you need a relatively good source of power, they're a good choice. But don't power any medical equipment or extremely important, like show-stopping critical equipment off of this because A, the inverters might go bad, and B, the modified sine wave might not be the healthiest thing for all of your high-end electronics. So definitely I give these at least probably between a B plus and an A. I would have given them an A plus, but since one of them did fail when I first bought it, I'm not going to give it quite an A plus, so I'd say B plus on these inverters. So thanks for watching my video. I hope that you can gain some information about this. I might do future videos on higher end inverters if I happen to acquire one, But for now, these have suited all of my needs, and I'm going to probably stick with using the SENTEC inverters. It occurred to me in a previous video, I did erroneously refer to this as a Chicago Electric inverter. Chicago Electric does make some large inverters, but Chicago Electric is normally Harbor Freight's power tool subsidiary. SENTEC, rather, is their inverter company. So SENTEC inverters, probably a good choice. And thank you for watching Dielectric Videos. See you next time.